Hi, this is Mrs. Tellas. We're going to start solving literal equations today. So there's a little of this in 1.2 and 1.3, and then it has a whole section in 1.5. So this is going to be our first day of literal equations. And we're going to solve them just like we solved the other ones. They just have a literal equation has more than one variable in it, not just an x. So for example, on this number 1, it says solve for the particular variable, solve for x. So we want to solve for x. We want x to be in the front all by itself. So we're going to go through the same steps that we went through before. So my first step is subtracting y on both sides. Now normally we subtract a constant in the other lessons, but there isn't a constant. There's a y, a variable. So we subtract y on both sides. And then we need to get rid of the 3 so x can stand alone. And the 3's cancel on the left, which is exactly what we wanted. So my answer ends up being like that. I'm going to go ahead and put a parenthesis around the 10 minus y. Okay, so you know you're finished when the letter that you're solving for is alone. Everything else has been moved away. So in this case, in the one we just did, we moved the y away first, and then we moved the 3 away from the x second. Okay, so this is slope-intercept form. Hopefully that looks familiar to you from last year, but we want to solve for x, and x is right here. So in order to move things away from x, the first thing I'm going to do is subtract b. So this is y minus b equals mx because those canceled. And then since I'm solving for x, I'm dividing by m. So my answer is y minus b, that quantity, all over m. That's my answer because the m's canceled in the second step. Okay, down here we've got 3 variables instead of 2, but it is the same thing. This time I'm solving for y, so I want y alone. So I'm going to be moving things away from y. Constants, variables. All right, so first thing I could add or subtract away would be this 4x right here. So I'm going to subtract 4x on both sides. Those are going to cancel. Negative 3y drops. And we have z plus 8 minus 4x. And you could put that 4x in the front. I didn't really want to because it's a negative, but it doesn't matter. And then I'm going to divide by negative 3. So the negative 3's cancel and y drops. And this is z plus 8 minus 4x over negative 3. Now, we don't usually like a negative in the denominator, so what I'm going to do instead is I'm going to change the signs, all 3 of the signs in the numerator, and just make that a regular 3. And I'm going to put the 4x in the front too. So negative 4x would become positive 4x. Positive z would become negative z. And positive 8 would become negative 8. So all I did was take this negative and change all the 3 signs up there, and then I also moved the 4x to the front, so it was in proper form. Okay, this is a new one. You wouldn't have done this one probably in pre-algebra. So we want to solve for b here. And notice that b is in 2 places on the left side or the front of the equation. So what we have to do is we have to factor out the b. So I'm going to put the b in the front with a parenthesis. And when I factor, I divide out the b. So I factor out the b from that one, this term, and that leaves me with a. And I factor out the b from this one, and that leaves me with positive c. So you have to think about if you were distribute, wouldn't that give you the same thing it was? So it's kind of like undistributing the b from what it was. So it's like putting it in its proper form with a quantity, using the undistributing or using factoring. All right, so now since I want b alone, I can just divide by the whole parenthesis. And those cancel on the left side, which is exactly what we wanted. We wanted b to be alone, and this is my answer. Okay, number 5 is similar. I want you to try number 5. I want you to pause it. Try number 5. All right, notice that we're solving for y. So there's 2 y's. Okay, when there's two y's and we need there to only be one y, we have to factor. So we put the y in the front and we put a parenthesis and we divide y by both of the terms so I can pull the y out. So in the front term, when I pull it out, it leaves me with x. And in the back term, y divided by y is 1, and it's negative because there's a minus sign. So minus 1. So now I'm dividing by the quantity x minus 1. So those cancel, and my answer is z over the quantity x minus 1. Did you get it right? Good job if you did. Okay, this time we are solving for p. This one's different. We're not going to factor because there's only one p. Now, if I were solving for n, I would have to factor, but it says to solve for p. So let's see, I'm going to make a t. I'm going to move this n over by subtracting n. The n's go away, np drops. And then I'm dividing both sides by, let's see, I want p alone, so I'm dividing by n. So p drops. This is m minus n all over n. Now, I could leave it like this. That's a perfectly acceptable answer. The other thing I could do would be to divide it up, if I wanted to, as m over n minus n over n, which this one will cancel because anything over itself is 1. So we could change this if we wanted to p equals m over n minus 1. This is also a correct answer. This is easier to do. You just leave it like that and it's perfectly acceptable. That's what I would do. Okay, let's try this one. So we've got a nice fancy equation and we're solving for x. Count how many x's there are. There are 2. So when there are 2 x's, you have to factor out the x. So you will put the x in the front. And then you will factor out the x for both. If you haven't tried this by yourself, try it. So we're going to do m plus 2n because the x's are going to cancel for both. And there are things left over, so that's what's left. And then we're going to divide by that quantity, m plus 2n. And that's going to be our answer because those cancel. That's my answer. Hopefully you got that right. Good job. Okay, let's try this one. So we're going to solve for b. So as I look at this one, it's got a parenthesis, and my instinct is to go ahead and distribute, but I think distributing might make that harder. Maybe not. Let's try to distribute. So if we do 5 times a and 5 times b, that would be 5a plus 5b equals x. So then we could go ahead and subtract 5a on both sides. X minus 5a, and then divide both sides by 5. And I would leave it that way. That's a completely fine answer. Now the other way I could do that, let me do it one other way. The other way I could do that, if I wanted to, would be, because I have this 5 here, I could divide both sides by 5. And that would cross out. And then I have a plus b left. And then I could subtract a. And that would also be a correct answer. That would be still alone in the front. I just did it a kind of a backwards way, and that's totally fine. Both ways right. Okay, let's try this one. So since both of them have x's in the denominator, we are going to have to multiply all 3 of the terms. This one, and this one by x to get the x's out of the denominators. So if I multiply this one by x over 1, and this one by x over 1, and also this one. So those cancel, and I'm left with a. These cancel, I'm left with minus b, and over here I have cx. Because I want x alone, I want to move the c, so I divide by c. So a minus b is on the top, and that's my answer. I hope that makes sense. Okay, let's try this one, the ones with the fractions. Number 10. So it says, really that 1 shouldn't be there. BHC over 4 equals m. And I want to solve for h. So I want this h alone. I want the 1/4, the b, and the c on the other side with the m. So anytime I have a fraction, I'm going to start with the fraction. So just like in section 1.1 and 1.2, whenever you have a fraction in front of a variable, you multiply by the reciprocal. So I'm going to multiply by 4 over 1 on both sides. Okay, those 4's are going to cancel, and I'm left with BHC equals 4 capital M. And then I'm going to divide because B, H, and C are all multiplied. I just want to get the B and the C away, so I divide by BC. So I'm left with H equals 4 capital M over BC. That's my answer. So anytime you have that fraction, you want to multiply by the reciprocal. Here for H, if you want to press pause and try this one, I'd love that. Okay, so there's only one H. There's no reason to factor because there's only one of them. So first step would be to subtract 2G. Anytime I can add or subtract something away, I do that first. And then I could divide everything that's in the way. And the only thing I want left is this H. So I'm going to divide 7, G, and I. And the reason I can do that is because they're all multiplied. So doing the opposite divide would get rid of all of them. So I'm left with H on this side, N minus 2G over 7GI. That one was tough. If you got that right, good job. I'd like to do another one with the fraction if we have one. Oh, I've got some that are story problems. It says, what is the width of a rectangle with a length 14 and an area of 161? Well, the area of a rectangle formula is A equals L times W. It says the length is 14 and the area is 161. So we plug in 161 equals 14W. Well, we can solve this. This is just a one-step equation. So 161 divided by 14, let's see what that is. 11.5. So my width is 11.5. So really, these are just plug-in checks. If you know the formula, you can put it in and then use your solving skills. Let's try this one. So a triangle has a base 7 and an area, it's missing the A, 17.5 meters squared. What's the height? So formula for area of a triangle is 1/2 base times height. So I know the area. I know the 1/2 is there, and I know the base is 7. And I'm looking for H. So half of 7 is 3.5. So I'm going to divide both sides by 3.5. Let's see what that gives us. 17.5 divided by 3.5 is just 5. So my height is 5. Okay, so I'm all finished. I want you to go back, go to Canvas again, and then log into Big Ideas and do that assignment. It's a very short little assignment for day 1.